Okay. So we got a topology where you can learn the attribute behavior, tuning of attributes. Router 2, 3, 4 and 5 are already running BGP. Repeating again, router 2, 3, 4 and 5 are already running BGP. And router 5 is advertising that 55 network. It is advertising it. So if you go to router 5, you can see that. Show IBGP, see? This 55 network is advertised. And we will be receiving this on R2 and R4 now. Let's check R4, which is immediate autonomous system in the lift. Show IBGP. R4 is also learning it. See, it's learning from autonomous system for Android. Next up is the IP address of the next autonomous system, which is router 5. Now let me show the same output on router 2. Show IBGP. Router 2 also says, I learned via these two paths. Router 2 says, I learned it from 3000 and 3000 has learned it from 5000. For router 2, this is the next stop. And it appears to be valid and best. Check the routing table, show IP route BGP, you have the route. Likewise, router 4 also should have the route. Show IP route BGP, we have the route. Now what I need to do, I need to run BGP on router 1, 7 and 6. Let's run BGP. Router 1, I'm already running OSPF within the autonomous system 1000. As a result, I can ping 7.7.7.7, which is the loopback address of router 7. So see, there is a reachability between loopbacks. We may use this one also to form neighbor, the loopback. So let us form neighbor using loopback within IBGP environment. I'm not going to make full mesh. Ramesh, what is making full mesh mean? Yeah, what is it? Making full mesh means what? Router 1 forming neighbor with router 7 as well as router 6. That is full mesh, right?
Yes.
Full mesh is forming neighbor with everyone. But I don't want to do that. Why? More neighbors you have, more BGP sessions need to be maintained. More process will be utilized. More bandwidth will be consumed. I just want to form neighbor only between router 1 and 7, 7 and 6. I do not want to do this one, 1 and 6. I do not want to do that. I don't want to have full mesh. But we learned about BGP, IBGP split horizon rule. To overcome that, we need full mesh. There is also another solution for that which I am going to teach you today. That's right. I am not going to make full mesh. Now going back to router 1, I say your neighbor is 7777, remote AS is 1000, and whenever you speak to the neighbor, use the update source. Done. See, only one neighbor we have saved. We are not saying router 6 as a neighbor. Likewise, I'll go to router 6 and say router BGP 1000, neighbor is 101.1, remote AS is 1000. The neighbor update source. Oh, sorry, I'm making a mistake. Not 1111. 777. How can we are not making full mesh? I said. A mistake. I removed it. Neighbor 7777. Remote AS is 1000. Update source level 0. Alright. So router 6 is forming neighbor with 7 and 1 is trying to form neighbor with 7, but router 7 is not yet configured. Let's bring router 7. Router BGP 1000, neighbor is 1111, remote AS is 1000, update source. Next neighbor is 6.6.6. Remote AS is 1000. Update source works. Done. So we'll see now two IBGP neighbors from router 7. Then we got it. Show IBGP summary. You see, you got two neighbors. Both are IBGP neighbors. But there is no prefix learned so far. No prefix learned. Now what is next? For bringing the external network, I need to form EBGP between R1 and R2. Show IBGP, there is no route because I don't have EBGP neighborship. Only IBGP we have. Let's form EBGP now. Router BGP 1000, neighbor is 125.12.0.2, remote AS is 2000. The neighbor will easily come now because router 2 is configured already. See, the neighbor has come. Likewise, let me go to router 6. Neighbor 145.14.0.4. Remote AS. What is the remote AS? 4000. Now here also the neighbor will come because router 4 is already configured to form neighbor with 6. Just come. Now you see, show IP BGP, we got a route learned on R6. R6 says, I'm learning this network from router 4. Router 4's autonomous system is 4000. And 4000 is learned from 5000. Is it right? 4000 is learned from 5000. So R6 got the route. I'm showing in R6. The same command I would like to show you on R1. R1 also has learnt it. But what is the difference? You see, R1 is 3 hops. R6 is, why R6 is only 2 hop? Is it true? You see, via R1 it is 1 hop, 2 hop, 3rd hop only will reach here. But here it is not like that. 1, 2. you'll reach. Fine, whatever. No, that is not our story. We'll talk about that later. We got the routes, and I want to see the route on R7. Earlier R7 was not learning any network, but now it should learn one prefix. What is that one prefix? Cut the summary and type show IBGP. This is that one prefix. But none of them are best. It is only valid. My question is why it is not best. If it is not best, it won't be seen in the routing table. You see, it's not there. We don't have route in the routing table. We have it in the BGP table, but not in the routing table. But in router 1, if you check, because it is valid and best, show IP route BGP, you should see route. See, the administrative distance is 20 because it's EBGP. Likewise in R6, show IP BGP, show IP route BGP. We learn the route and it is EBGP. We are learning the route in R6, we are learning the route in R1. Why we are not, though we are learning on R7, why we are not seeing the route? See, there is no route. But route is saying one stop self. Next stop self, very good. Why? Because this next stop is the next stop which is carried into IBGP. This is the next stop of EBGP. R7 do not know where this next stop is. See, ping and see. R7 has got no idea where this next stop is. Neither this next stop nor that next stop is known. This is what we learned. The next stop need to be a reachable one. That is the very first point. Considers only synchronized, meaning routes with no AS loop and a valid next hop. The valid next hop is not seen in our router 7. The next hop is unreachable. The next hop is unreachable. So, to fix it, what our Murli said is what the solution is. I need to go to router 1 and say, router 1, just say yourself as a next stop. Router BGP 1000. Neighbor 7.7.7.7. Whenever you send anything, put your own address as the next stop. That's the meaning. R6. Router BGP 1000, neighbor 7.7.7.7, next stop self, done. After this, we will have valid and best route. See, here it is changed, but this is not changed. It will take some time. So when this is a reachable next hop, even though the other one hop count is less, just 2 hops, this is 3 hops, even though this is a long route, it accepts this as the best one. Why? Because the next stop is unreachable. But if you leave some time, okay, now you see the next stop is changed. Now you see the best is different. Earlier the best was here, but the best is now via 6. You know why? Because less hop, less AS. Let's go back to this page. You see here, If both the next stops are valid, it will check the weight. What is the default weight here? 0, 0. So there is a tie. Then it will check the local preference, highest local preference, but both local preference are 100. So there is a tie. Next it will check if any route has got next stop 0, 0, 0, 0. But both the routes have got some number, not 0, 0, 0, 0. It's not self-originated. So there is a tie again. So this is the tie breaker, the shortest AS path. So only when there is tie in this above, the shortest AS path will become a tie breaker. You see, this is just the 2 shortest, whereas this is 3. So this has become the best. We can check it in the routing table. Show IP route BGP. You can see the next stop is via router 6. That's what we saw in the BGP table, the next stop. Why this is the selected route? Why this is the next stop? Why this is the gateway for this destination? It is all because of the shortest AS path. Any question? Currently it is because of the shortest AS, the path will be via router 6. If the AS is shorter, if the AS is same, then it will come and check this one, this one, this one. It will pick based on any one of this, which we will be seeing in some other scenario. We will change the scenario and we will see. First, let's learn something more about these things. Now, right now it is using this attribute. What about these 2 attributes? Let's try to tune something and see. Now, router 7 goes via router 6. What if router 6 fails? It will go via router 1. Because it knows another path, which is via router 1. Now, let us assume, focus on the question. Let's assume we want this path. The reason is the bandwidth here is very high. The bandwidth here is very high, let's say 10 gig. Here the bandwidth is just 100 meg. BGP will not see bandwidth, no? It won't focus on bandwidth. So your policy is, you got 2 ISP connection. One is a cloud, you got 100 gig, 10 gig connection. You paid for 10 gig. With another ISP, this is another ISP for you. I'll call ISP B. With another ISP, you just got 100 meg. Currently, all the traffic is willing to go this way. Currently, I showed you in the routing table, they are trying to go this way. But you want this path to be a backup path only. You want the path to be via 10 gig link. So what you can do is, you can set local preference. But before that, if R6 needs to go via R1 like this, R6 should know that there is a route via R1, but it don't know. R6 do not know. I'll show you. Oh no. R6 will not know about another path. Look at this. Show IBGP. R6 have got only one path. That path is via router 4. You know why? R7 knows that I have path via router 6, I can go via router 6, I can go via router 1. R7 knows that there is a path this way, there is a path this way. But R6 knows only this path. Likewise, R1 knows only this path. R6 do not know there is one path like this. Likewise, R1 do not know that there is one path like this. Why?
R1 and R6, we don't have connections.
R1 and R6, we don't have both logical or physical connection. That is true. We don't have a physical wire between R1 and R6. So I can take that as an answer from your answer. Or you also say, we have not formed full mesh. We have not formed IBGP between R1 and R6. That is also answer for your answer. You simply say connection. It may be a physical connection, it may be a BGP connection. None of that we have. That's right. What Ramesh said is correct. Now, what is the solution for that? We used to form full mesh, which I am avoiding because having another session, another BGP session, will increase the load on my routers. So there is a solution called route reflector. What I'm going to do is, I'm going to break this rule which says route learned from an IBGP should not be given to another IBGP. That's the rule that is blocking R1 from learning this path. Same way, route learned from IBGP should not be given to another IBGP. That is the rule that is blocking R6 from learning this path. We are going to break the rule today by using route reflector. Earlier we used to make full mesh and break the rule. Now we are going to tell R7, it is okay. You can give the routes. By default, for preventing loop, route learned from an IBGP should not be given to another IBGP. R6 and R7 are what relationship? IBGP. So route learned from an IBGP, this route, this network that is given by router 6 to router 7 will not be given to router 1. But we are asking to give. By configuring route reflector, we are asking to give. That is how we break the rule. When you ask R7 to give to R1, R7 also can give it to R6, whatever it learned from R1. So you no need to say bidirectional route reflector client. Understand, repeating again. You did not understand. You did not listen carefully. I am repeating again. I'll go to R7 and say, it's okay, you can give the route to router 1. When you say that, what will happen? Whatever R1 gave also will be given to R6. But did you ask R7 to give it to R6? No, it will be automatically done. When I go to R7 and make R1 as a client, R6 will become a passive client immediately. You can say anyone as a neighbor, route reflector client. In R7, if you say R6 as a client, R1 will become automatically a passive client. So the route that is given by R1 to R7 will be now forwarded to R6. Same way, whatever R6 gives to R7 will also be forwarded to R1. Let me do and show you. I am in R7. Currently, if you go to R2, not R2. Currently, if you go to R1 and R6 and type show IP BGP, you don't see route via R6. You are seeing only one route via R2. It is because R7 did not give the route to R1. R7 is the middle router now. R7 knows about both the routes. R7 is not giving this route to R1. Do you see that? You don't see. Let's make that to happen. I'll go to R7. Before that, I also want to show you in R6. In R6 also you don't have a route via R1. You don't know. You have only one route. Only the EBGP routes. Both in R1 and R6 you have only EBGP routes. Via IBGP you don't have a route because R7 is not giving. Let's make R7 to give. How? Go to R7 and make any one as a client. Any one. Either R1 you make it as a client, R6 will automatically become a client, or make R6 as a client, R1 will become client automatically. How? Like this. Router BGP 1000 neighbor 1.1.1.1 is a route reflector client. That's all. Just one side you make, the other side will become client automatically. Let me show you now. If you go to router 1 now, earlier we were having only one path via EBGP, but now you have two paths. One via EBGP, the other one via one via EBGP, the other one via IBGP. See, earlier router 1 was going via the long path. Why? Earlier router 1 was going via this long path, but now it is going via the shortest path, just 2 years. Why? Because earlier this route was not given to router 1. Router 7 was not giving it. Now router 1 knows that I can go this way. I can go this way. If it comes this way, it is only 1 and 2 hops. Yeah? Only 2 hops. So, route reflector works. Likewise, you go to router 6. Earlier, we were having only one path. But now, you'll see 2 paths. It will come. It has to come. Why it is not coming? I'll tell you the reason. It won't come because of another reason. You see, router 1 was going this way, which is a long route. Router 7 says, I am going via this path because of shortest AS. Going via the shortest AS is the best path, and the best path is advertised to R1, and R1 is using it now. Not this way, R1 is using this way now. R6 is now knowing only this path. R1 is not the path to go. Why? Because R7 will not give. R7 will give only if this path is the best path. This is not a best path, no? Why R7 should advertise a path which is not best? R7, you see, according to R7, show IBGP, which one is the best? Going where 6 is the best. Why? R1 says, I will not give you route via 2 because route via 2 is not the best. See, R1 has filtered this route because for R1 this is the best. So R1 itself is not ready to go via router 2, so it won't advertise the route to router 7. So both router 7 and router 6 now do not know about the long route. The only router who knows that long route is R1. R1 knows about both the routes. And R1 has filtered the route via R2 because it's a long route. As a result, R7 and R6 do not know about that route. Now, if you want R1 to go via router 2, what should I do? If I want R1 to go via router 2, what should I do? Set wait. Right now, how it is going? R1 is going via router 6. It's IBGP. It goes like this. But if you want to force it to go via this way, what I should do? I should set weightage. If I set high weightage here, currently the tiebreaker is AS path. But before AS path comes what? Currently the tiebreaker is shortest AS path. But before AS path comes the weight. So if I will change the weight, here as 10, this greater than symbol will jump here. And this will become a best. And then this will be advertised to router 7 and router 6. Let me do and show you. I'm just setting weight, you see. Router BGP 1000. Neighbor. For this neighbor, I'm giving more weightage. Weight 10. Now the weight will be changed. Clear IBGP start soft. I'm refreshing BGP by clear. Show IBGP. Now you see, though it is a long path, because the weight is set, it has become greater. Now router 1 is going via router 2, not via router 6. Show IP route BGP, you can see it's going via router 2. Now for router 1, the best path is via router 2. Now if I go to router 7, you will see both the routes. One via router 6, the shortest is, another via router 1. Even though it is long, it is seen here, but it will not be used because weight is local to the router. I set weight on router 1. It is local to the router. Router 1 is going via router 2, but router 7 is going via router 6. Likewise, router 6 will also be going via router 4. Why router 6 is not seeing route via router 1? Because R7 will not advertise this route because it is not a best route. For R7 this is not a best, so it will not advertise. It will not advertise it to router 6. So router 6 do not know about the long route. If you want that router 6 to know about this, then go and set weight here also. If you go and say high weightage to this neighbor, then this will start using the route and it will start advertising the route. Anyway, whatever I have taught you today may take some time for you to understand. Only when you do. While you do, if you watch this video, then only it will be clear. Whatever the explanation I give, if you are not able to understand, then you have to start doing it. Try doing this lab. Check whether you understood everything that I said in today's lab. We have just started this attribute lab. We have not gone deep. We have not started using route maps, nothing. So, build this topology in your laptop. Try understanding what all I have explained here in this video. Come in the next class. We'll continue this.